Uh, so we'll actually record this session so that it is helpful for many other students. That's the whole idea. And I'd like you to watch the recording after the class. If you have any doubts, write the comments. If you have any questions, write those questions. I'll be there to answer all those questions. Perfect. So let me introduce myself. I'm Anil Kumar, and I love to teach math. We have an excellent group here. All the students want to learn advanced functions, right? Some are IB students, grade 11. Some are of grade 12 students. And this is the advanced functions course, which is followed in Ontario, Canada. Now, I'd like Hamza to introduce himself.
My name is Hamza. I live in Oakville, Ontario. I completed functions, grade 11 functions last year, and I'm going into grade 11. So I'm trying to take advanced functions this year so I can take a future math course in grade 12. So I'm really interested in learning so.
Vishruta.
Hi, my name is Vishruta. I did functions about last school year. I'm doing advanced functions over the summer, so next year I can be ahead.
Very good. Akshit.
Hi, my name is Akshit Candyvanam. I did functions last year, so I thought it would be best to prepare for advanced functions as it is a crucial topic.
Muhammad.
I'm Muhammad, and I'm a grade 11 student, and I want to take advanced functions in advance, so when I go to grade 12 or grade 11, it's going to be much easier for me. I'm getting ahead of the game.
Very good. Advanced functions, much in advance. That's very good. Ankita.
Hi, my name is Ankita. I'm going to grade 12. I'm from Brampton. I did take functions back in November, and advanced functions is really crucial. It's a requirement for post-secondary, so I would really like to get ahead.
Sure. So we'll actually talk about absolute functions today. Now, let me tell you one thing, that in your book, most of the books which are being followed here, absolute function is just one-page chapter. One-page chapter and 2 pages of exercise, just 3 pages in the whole book, right? But you will be like surprised to know that in the test, you're going to get 2 questions from this particular chapter. And more than that, only 25% students will get both the questions right. 75% questions will get them wrong. This I can give you in writing because I have seen this over the last 10 years. You get my point? That is the importance of today's lesson. And therefore, Vishruta, I actually invited you well in advance so that you get ready with advanced functions right now, correct? Most important chapter of Unit 1, absolute functions. And this particular concept of absolute functions will be highly used in all our lessons, coming lessons, and also in calculus, where we'll talk about domain range and so many other things, right? So let me just share with you what I've prepared, then we'll begin from there. Okay. Can you all see the screen, please?
Yes, sir.
Very good. So first, does anybody has idea about what is an absolute function? Any idea? You have heard the term?
I just know that, like, for example, like -1, like the absolute value of like -1 would be 1, like any negative number would become positive.
Any negative number becomes positive? Absolutely correct. That is right. So that's the base of it. And we'll now look into what really absolute function is. It is also called the modulus function, correct? That is also another name for it. So we are going to use that modulus also as a name. It is basically a piecewise function. We will see how do we write an absolute function as a piecewise function, right? So once we understand that, then we'll work with many equations involving absolute functions. So we'll solve equations involving absolute functions. We'll also look into inequalities. So I've kind of extended the scope of this particular chapter. What I'm going to talk about is not just this one-page chapter, but in a way, the way absolute functions are going to be utilized in advanced functions and also in calculus. So that is why it now becomes extremely important, okay? So we'll look into some other inequalities, and we'll see how do we relate with double inequalities, and we'll also see solutions which we can find using graph. Then I'll have some practice questions, some test assignments, and some extended questions for you in today's lesson. Okay, let me first begin with my most favorite question. And I like Hamza to first answer this question. The question is, what is square root of x squared? Can you tell me, please?
Okay, I feel like this is some sort of a trick question because
it is.
Would it just be x because the squared and the root cancel out, or would the operation happen inside?
Okay, we'll now take the answers from Vishruta. First, Mohammed, tell me, what is square root of x squared? Do you agree with Hamza or not?
Yeah, I think so. Because if you square root it, I think it's x as well.
Anybody who doesn't agree with Hamza, he will be right. Okay, Akshat, tell me, what is square root of x squared?
The absolute value of x.
The absolute value of x. First question. Now you realize the power of this one-page chapter. Do you understand what I'm saying? 75% students will always get it wrong. Only 25% students will get it right. That is the point which I'm going to prove, and I've proved it before you. You get my point? Now, you'll be still surprised that how come? It is absolute value of x. We are squaring something and then square root. We should get the number back, right? It is a function, right? We are doing the inverse of that function, correct? And therefore, it makes sense that we should get the same thing, right? But see, look here. If I do 7, right? 7 is my number. Let me write x equals to 7. In that case, what is square root of 7 squared? Well, it is 49, and square root is definitely equal to 7. Then in that case, it seems to be correct. Okay. How about minus 7? So if I use minus 7, then if I square it, what happens? It becomes 49. And what do I get? I get 7. But I started with x equals to what? Minus 7. It is not minus 7. Do you see that? All of you. Hamza, is this point clear to you?
Yeah, it makes sense. I didn't realize that. But basically,
it is positive value of 7. That means absolute value of minus 7. Is that clear? Correct. So absolute value is always positive and square root is always positive. As we saw in our last class, that square root function, if I sketch, how will the square root function look like? It is like this, right? That is my square root function. It has a domain of all real numbers which are greater than equal to 0, and range also all real numbers greater than equal to 0. It makes sense. If I do x squared, everything becomes positive, correct? So in my domain, I could now write any number, right? Because when I square a negative number, it becomes positive. And therefore, I'm able to find this particular value for each and every value of x. So what I'm trying to say here also is that the function x squared square root has a domain of what? Domain is x belongs to real numbers because x squared makes them non-negative, and that is why, correct? So this is very first thing to understand. Square root of x squared is absolute value of x. In calculus class also, this is going to be my first question. I'm reminding you, this is going to be my first question, and based on this, we'll find the limits, okay? Very good. So we have understood absolute value of x, kind of. Now, how do we really relate to it? Let us say, I actually live very close to the airport, right? For me, when I took a job first, then, I had to travel a lot to US and other countries. So I thought I should be close to airport. So I decided that I should be within 5 kilometers of the airport, right? That means it doesn't matter whether I'm living in the north of airport, south of airport, east or west of airport. Absolute value means 5 kilometers around airport, correct? Somebody may decide they don't want to live near a fish market because it smells a lot. They will say, well, the absolute value should be greater than 5 kilometers. That means they can live anywhere, but not within that 5-kilometer region. Do you understand? So that is how we relate inequalities with absolute function. You get the idea? So if I write, let us say, if I write this, the absolute value of x is less than 5, it really means that x is between 5 and -5. Do you see that? That is what it means. And if I write that absolute value of x is greater than 5, it means that x is either on the left side of -5 or is also written as union, or x is greater than 5. Do you see? Away from, outside that particular zone. You get the idea? So that is how we are going to use absolute function in inequalities. You get the idea? So we are going to find a lot of applications of absolute function in solving equations and in solving inequalities. Correct? Is that clear? Okay, so let's move forward and first understand what is this absolute function. So let's do some math, which Hamza said first. As you all know, what is absolute value of 7? Well, it is 7. Absolute value of -3 is 3. But if I have 2 minus 6, then 2 minus 6 is -4. Absolute value is always positive. So it is 4. And we just learned that the square root of x squared is absolute value of x. It is always positive. This is what we have seen. Correct. Now, in real life situations, many times, we have many examples. We say, well, tolerance, for example, correct? Let us say you want to buy a piece of wire, let's say rope, okay? So you want a rope which is, let's say, 1,000 meters, right? You say, well, give me 1,000 meters of rope. You say, well, 1 or 2 meters, plus or minus, doesn't matter. So within the limit of plus or minus 1 meter. You get the idea? So either you get 1,001 meter or 999 meters, it is kind of okay for you. Correct? That is our tolerance, right? That is the accuracy which we are looking into, correct? So when you are measuring distances using a ruler, for example, you can see on a ruler you have centimeters and millimeters, correct? So the most accurate thing you could measure is some 1 millimeter. So you have a tolerance of 0.5. It could be here and there. Do you see, get the idea? It is either a left of or right of that particular point. So if exact value is, let us say 10.16, you will say 10.2 because we can just measure that much accurately using the ruler in this particular case. So in all our measurements, we have some accuracy involved, some approximation involved, and we use absolute function. It could be plus or minus that particular value. So in general, it is the tolerance which is acceptable for saying that this material is acceptable, correct? So that is what we say. Similar examples, we could say, as I said, distance d less than 5 meters is written as absolute value of d less than 5. It could be on east, west, north, or south direction. You will soon learn vectors, and in vectors, direction is very important. We say, well, north is positive and south is negative. So that is why we have kind of given you this idea, the absolute value and its importance to vectors, which you are going to learn at the end of your grade 12, okay? So, and in temperatures also, we have seen the tolerance. Every time we forecast something, we say, well, the temperature will be plus or minus 1 degree, but around 20 degrees, for example, correct? So that is how we use absolute functions. Now let us see, how do we interpret graph of an absolute function, okay? Ankita, are you with us?
Would you like me to read the questions?
Ankita, I cannot see you on the screen. Okay, you are there with us, right?
Yeah, I'm here.
You are, okay, that's fine. Very good. Okay, that's fine. Okay, so now I will show you graphically what an absolute function is so that this concept is absolutely clear. Let us say you want to sketch a line. So we'll begin with a sketch of a line, which is y equals to x. As you know, y equals to x is a very straight line going through the origin, dividing the coordinates diagonally, right? This line, as you can see, is symmetric about the origin, correct? Like this. if you want to sketch this line, what do? You take some x values, and the key values which you take are 2, 1, 0, minus 1, minus 2. And since y is equal to x, the y values are also exactly same. And when you plot these points on the graph and connect them with a solid line, you get the graph of the line y equals to x, correct? Nothing, you have done it so many times, perfect. But what is absolute value of x? We just learned that absolute value of x means that we cannot have this negative part, correct? This is the part which we cannot have. When it was minus 7, you made it 7, correct? So when it is minus 1, you will make it plus 1. Minus 2 will become plus 2. And therefore, this part gets reflected, as you can see. And what do we get? We get our absolute function, which is shown in green. Perfect. So that is the absolute function. As soon as you make that curve, you see that x is always greater than equal to 0. It is non-negative. Perfect. Is that graph of absolute function absolutely clear to all of you? Okay. So now I can say that if x is less than 0, if x is less than 0, that is, if it is in quadrant 3, in that case, what do? You reflect it on the x-axis. Reflection means, minus of x. That is the reflection. A value is negative, vertically reflected on the x-axis. So if x is less than 0, then the value of absolute function will be negative of that x value. However, if x is greater than or equal to 0, then the value will be exactly same, as you can see here, right? So in the quadrant 1, it is exactly same. But in quadrant 2, it is a reflection of the line which was in quadrant 3. And so you got this absolute function, which is kind of a V-shaped graph. This graph is now symmetric to what? It is symmetric to the line y-axis, correct? So it is symmetric, right? So these 2 points are equal distance. We say this is even symmetry. You see that function, the line, has an odd symmetry. Odd symmetry means symmetric to the point. That is to say, if I have a point here, there is a reflection and we have the other point. As if a mirror is there at the origin and you say you get equal and opposite image, correct? In this case, the mirror is along the y-axis, and that is symmetric along the y-axis, and we call the function to be even. Is that okay? Is up till here everything clear to you, right? Any doubts? Perfect. So now most important thing which we have come across is the basic definition of absolute function. As you can see, highlighted right in the middle, absolute function is now split into 2 functions, and therefore we also say it is a piecewise function. One piece to the left of y-axis, the other on the right. When the value of x is less than 0, in that case, the value of y is negative of x. But if x is on the right of origin, in that case, the y value is same as x, y equals to x. And that is what absolute function is, correct? Now, can you tell me, what is the domain of this absolute function? Anybody?
All real numbers.
What is the range of absolute function?
Y is an element of all real numbers such that y is greater than or equal to 0.
Greater than equal to 0, perfect.
It can be less than 0. Oh, yeah.
It can be less than 0. It is non-negative. When we say non-negative, 0 is included, okay? When we say positive integers, 0 is not included. Non-negative, 0 is included. Is that okay? So when I say sometimes, this is a real number, of course, but if I say z is for integers, z plus will be positive integers, 0 not included, okay? So if I have to, it is not really related with this topic, but anyway, if I write z plus, it means z is integers 1, 2, 3, 4. Do you understand? But if I have to include 0, I'll say 0, 0 plus, and then 0, 1, 2, 3, 4 are included, okay? And if I say z itself, then you know plus and minus numbers are included. You get my point, right? Anyway, but we are talking here about real numbers. But I took integers mainly because when we have examples where items are considered, number of items, in that case, they will not be split into all the real numbers, correct? We'll be talking about the natural numbers most of the time, or the integers, right? So we'll use this concept there. Now, let us review the characteristics of absolute functions. Here, you can see a table. Now in the table, what I have done here, this is a very good format, and I have found that this format actually is very useful for all the students, and we can use it for any function. Today we are talking about absolute function. Is that clear to you? But if it is reciprocal function, quadratic function, polynomial, any function, we can make the same table. So first thing first, whenever we talk about any function, we should first define the function. What is the function, right? So in this case, the function is absolute value of x, which could be written as a piecewise function. That is my function. Now we are talking about the characteristics. So the characteristics are, first, any function, we should consider what are the key points. How do I graph a function? What are the points I should look into? And if I have to do a transformation, I will just do transformation of those points and get the new graph. You get the idea. So those are called the key points. Normally, we have 5 key points for any function to draw a graph. The 5 key points here are listed: -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So these are the kind of points which will give you this particular graph, as you can see. Domain, we understand, is all real numbers. Range is y greater than or equal to 0. Symmetry, we already know, is even symmetry. Even symmetry is a new term for many students, right? Maybe some of you also. What does it mean? Even symmetry means it is symmetric about y-axis, as you saw, correct? That is when we look at it graphically, perfect. But algebraically, what does it mean? It means in function notation, f of minus x equals to f of x. That is even symmetry. As you can see here, if I take -7, right? So what is this equal to? This is equal to 7, right? I mean, equal to 7. Do you understand? Both are same. So it is even symmetry, right? That is the trigonometric function cosine is even symmetry, right? So which you might have known. Parabola has even symmetry. For example, x squared, right, is also equal to minus x whole square, correct? Because if you do minus x whole square, you get x squared. That is what I mean to say when I say f of minus x is equal to f of x. That is to say, if you replace x with minus x, you get the same equation, which you started with, correct? You understand? Is this point clear to you, all of you? Even symmetry? Very important. For example, if I say y equals to x squared plus 3, then let me write function notation. Function notation, as you have seen, is very useful because we can explain more. Always writing y doesn't make sense. So what is f of minus x? Minus x will be replace x with negative. So you can write let me write 2 also here. How does it matter? So I'll have 2 times. I'm replacing x with minus x, right? Square plus 3. What is this equal to? This is same as 2 times x squared plus 3. And this is same as the f of x. Do you see that? So we got f of minus x same as f of plus x, right? The same function. And therefore we say this function is even symmetry, right? This function has even symmetry. Is this point clear to everyone? Very important. So we are talking odd symmetry is, I will discuss that later. But today, even symmetry. Okay, that's fine. Now, x and y intercepts, very important for any function, these 2 points. In our case, both are the vertex of the absolute function. So they are at the origin. So you can write x equals to 0. You can write origin. You can write 0, 0 coordinate point. Decreasing interval is another characteristics which is very important for functions, which till earlier we were not writing, right? Sometimes you were not writing. So when you describe a function, you have to write all these things: decreasing interval, increasing interval, and behavior and rate of change. Okay, all these points. Now let me just discuss what is decreasing interval. Decreasing interval is, so the x values which we are looking at, this is the domain. We always look into x values from left to right. Okay, so always check from left to right. When you read a number line, you read numbers from left to right, right? Right side numbers are greater. So now we have to see what is happening to this graph. You see this portion? It is decreasing, right? Coming down, correct? And therefore, the decreasing interval for this function is when x value is less than 0 on the left side of the y-axis, correct? So from minus infinity, you could also write this in another notation. From minus infinity to 0, the function is decreasing, correct? When is it increasing? It is increasing on the right side. So when x is greater than 0, it is increasing, right? Now, another important thing here is you may include 0 in either one of them or whenever you describe, but most of the time we kind of leave 0 in this particular case of debate, right? Then there is a debate whether I should take 0 on the decreasing side or on the increasing side, whatever. So if in a multiple choice, it is given on one side, you can always take it, right? Because you could start from 0 and go forward. Perfect. But safe is writing greater than 0 or less than 0, okay? End behavior. Do you understand what is end behavior? End behavior is when x value is very, very large or positive or very, very large negative, right? On those two ends, what is happening to the function? That is very important for us to understand. So we write like this. When I say x, this arrow thing here is approaches. So write down the word approaches. When x approaches minus infinity. Well, you can never reach infinity, right? Infinitely large number, but you can approach, you can go in that direction, correct? So that's it. So when x approaches minus infinity means when we are going in this left side, what is happening to the y value? Well, clearly, in our case, the y value is increasing and going to infinity, right? As you move left, the y value is increasing because absolute value is always positive. Minus 10 will become 10, minus 100 will become 100. Minus 1000 becomes 1000, very high values, right? So the y value also approaches infinitely large value. And we say when x approaches negative infinity, y approaches positive infinity. As you can see from the graph, do you see that? Right? What happens on the other hand, when x is approaching positive infinity? Well, in that case, as the line goes, the x value when approaches positive infinity, y also approaches positive infinity, and that becomes the end behavior of this particular function. Is this part clear to you? Right? Now, rate of change, as you learned in lines, that is the slope. What is the slope at each point? Well, on the left side, you know the slope is -1. That is the line which is coming down, correct? Y equals to minus x. On the right side, as you can see here, right? Y equals to minus x, right? F of x is same as y. And on the right side, it is +1, correct? So that is the rate of change. Now, can you tell me what is the rate of change at the vertex, that point on the origin? Anybody?
Sir, would it be undefined?
Okay, that's correct. Undefined really means you really don't know. What is the slope at this point, correct? Rate of change gives you the slope. Because at this point, I could consider this line also, right? I will say -1. Somebody else, no, at this point, this is also okay. Third person, why not this? Right? Any line which I draw, think like this. We have a table, right, on which we have something V-shaped. Then any line on the table becomes a tangent to that thing, correct? So which one is the right answer? There is ambiguity. Whenever ambiguity is there, we are saying we are uncertain. Uncertain means the thing is not defined. Just forget about it. So we say it is undefined. No debates. In algebra, if something is defined, absolutely clear, we write it. Otherwise, we say it is undefined. Done. You cannot precisely say what exactly it is. You get the idea? So undefined, and there's another term, does not exist. There are two terms. Write down the other term, does not exist. So if I have a multiple choice question, I will actually use both the terms. I will say the value is -1, the value is +1, the value is 0, the value is undefined, and the value does not exist. Now tell me what is the right answer. Does not exist or undefined? Very difficult question. We will go with undefined. It exists, which we don't know. You get the idea. It exists, but we don't know. Undefined, okay? So the rate of change is not known, okay? So we'll go with undefined. I'll show you examples where does not exist will be the right value. For example, let me just say, we have 1 over x graph, okay? You remember 1 over x graph?
Do you mean the square root graph? Oh, no, I remember.
Reciprocal function.
Okay, yeah, I remember.
1 over x. What is the value at x equals to 0?
Undefined, it never reaches 0.
It does not exist. The value is out of domain. It does not exist. It is not in my domain. Do you understand? Does not exist. Again, I'll give you the option undefined and does not exist. It is such a difficult question. But we can clearly see that x belongs to real numbers and x is not equal to 0. When it is not equal to 0, then this point does not exist. Do you understand the difference now? Correct? It is not undefined. It does not exist. What is the domain? In domain, we don't have x equals to 0. Then there is no question of asking what is the value at x equals to 0. It does not exist, man. You see that? That is how you have to interpret and answer this particular question. Is this concept clear till now? Vishruta, any difficulty?
No, I understand.
Perfect. Now, let's take a few more examples. What I've done now is I have shifted my line horizontally left or right, correct? That is what I've done. You can always shift a line, right? So if I have equation like y equals to x minus a, this is my line, correct? I'm not saying absolute value yet. So it really means what? Depending on the value of a, if it is greater than 0, then we shift right, correct? So then it becomes this line shown in orange. Is that clear? But if my a value is negative, in that case, it will shift left as shown on the other side, correct? Depending on the value of x. So if you want to draw a graph of x, let us say, in this case, I have drawn the graph of y equals to x minus 2, right? X minus 2 means what? X minus 2 means the y-intercept will be at minus 2, correct? So of course, this will be my line with a positive slope. This is another way of looking at it. Perfect. If I want to draw a line x plus 1, means that the y-intercept is plus 1 and therefore, that should be my line, correct? You can always find the x-intercept also, which is negative 1 in this particular case. So the line shifted left. Mohammed, is this point clear? How the line is shifting in the wrong direction, correct? So many times we think, why x minus 2 we are shifting to right? Well, substitute some points. If I write x equals to 0, 0 minus 2 will be negative 2, which is the y-intercept. So there you see, right? Y-intercept. And you can also find the x-intercept. 0 equals to x minus 2, that means x equals to 2. So x equals to 2 is this point, and therefore connecting these 2 points will give me the line. Clear? And literally, we can see now the line which was originally here shifted 2 units right, and that is what my transformation is all about. Now, what is the absolute value of this function? Well, wherever it goes to negative, I have to reflect it on the x-axis and make it positive. And that's what I did. Do you see that? So what I did was I just reflected my line, as you can see, and redefined it as an absolute value, which I did on the other side also. I just reflected this line and made it absolute value. So any function can be written as absolute function by reflecting the negative half, negative part on the x-axis, making everything positive. Is that clear to you? Correct? Let me...
I have a question.
Yes, sure.
How did the x minus 2 and then the next picture become x plus 1, or are those two different examples?
Those two different examples.
Okay.
I just wanted to take 2 examples to show you what happens when the a value is positive or negative. Correct?
Okay.
That was the whole idea. So, okay. Now here is a graph for me. This is the graph of x cubed. If I have to sketch graph of absolute value of x cubed, tell me, what should I do?
Sir, will you reflect the portion that is in the third quadrant into the second quadrant?
Correct. Simple as that. Nothing great about it. That is absolute function. Clear, right? Absolutely clear? No ambiguities. Very good. Another test question. Absolute value of x square minus 1. If I had to sketch this graph, how will I sketch this graph? Please tell me. Okay, I'm not seeing. Ankita, tell me, how will you sketch the graph of x square minus 1 absolute function? Ankita, are you with me? Okay, Mohammed, tell me, how will you sketch x square minus 1 absolute value?
It would be the parabola, right? Would you move it 1 to the right?
X square minus 1 is 1 down, right? X square minus 1 graph. So first I will sketch the graph of x square minus 1. That is, it will be parabola which moves 1 unit down, right? There is a difference. Right, it will go when I write x minus 1 whole square. Do you see that? There is a difference. When I write x minus 1 whole square, then it moves left or right. Do you see it is within the brackets? Outside the bracket means it is vertical. Within the bracket means horizontal. Be clear on this now. Okay, Mohammed? X minus 1 will be a parabola which will be kind of like this. But that is horizontal shifting from 0 to 1 on the right. But this is vertical shifting. Okay? So x square minus 1. Now, if I have to make the absolute function out of it, what will I do, Mohammed? Tell me.
You would reflect it.
Correct. Just reflect it, right? So this point was minus 1, that minus 1 now becomes plus 1, and that is your graph. Do you see you get these corners and the graph? That is your function, absolute value of x square minus 1. Is this clear to everyone? Any graph you can make absolute function by reflecting the negative part as the positive. Is that clear to everyone?
Sir?
Yes, both.
Sir, I just wanted to confirm. So for the question before, we just flipped the graph over the x-axis?
Yes.
Okay.
So the key here is we have to reflect the negative part of on the x-axis. Results in the absolute function of the graph. Is that clear to you?
Sorry.
Yeah.
So it's never the whole function, right? It's just whatever part is going past the negative,
yes,
past the negative domain. We just reflect that.
Okay. Never the positive portion. So once again, let's go and define our function. So if I am working with the absolute value of x minus 1, then you notice that if x is greater than equal to a, it is positive, right? Right side of a, it is positive, correct? So you do not reflect the right side of the a. But on the left side, you reflect it. Do you see this minus here? And therefore, now the piecewise function is written like this. Make a note of this. Only the negative portion. So we have to figure out what is the negative portion. That negative portion is at the vertex. You get the idea. Vertex is at A. And therefore, to the right side of the A, we'll have the same thing. But to the left side, we'll make it negative of that function, which is x minus a in this particular case. Clear? Mohammed, is this clear?
I was just kind of getting confused on when you reflected it. You see the green parabola.
Yeah.
The one you made. Why does the lines go back up after it hits the x-axis?
Okay. So in this green parabola, at this stage we have negative value, but we are looking into absolute value of x plus 1, which is always positive, which you can only get by reflecting it. And therefore, I could write this function as equal to what? I would write this as negative of x plus 1. So whatever this value is, we'll make negative of this. This is negative 1, for example, here, right? So it becomes positive 1. Do you see that? Because it got reflected. This was negative 1. it became positive 1. So when x is less than minus 1, because at minus 1 it is 0. So we have to figure out where it is 0. X plus 1 is 0 at x equals to minus 1, right? If I go to the left of this value, it will be negative. So therefore, I have to reflect it. So if x is less than minus 1, then the function becomes negative of x plus 1. But if you are on the right side, it remains as such. You get the idea. We include 0 on the right side most of the time. Mohammed, is this clear now? Okay, go through this video once again and our lesson. That is very important, okay? Very good. But I hope it is to some extent clear. We'll have many examples just coming fast. Don't worry. Now, we just defined our function that in general, we could translate our function left and right, for example, which is the simplest case. So when I translate it, then really it becomes, we have to find when is it 0? X minus a will be 0 at x equals to a, correct? So on one side it is positive because it's a straight line. It will never bend. On the other side it is negative. Wherever it is negative, reflect it. Reflect means do minus of the function. That is the reflection on the x-axis. And here it happens when x is less than a. On the left side of it, it is negative. Correct? So that is one piece. The other piece is as such as x minus a. Because it was earlier positive, so we don't have to reflect it. You get the idea? Got it? Let me give you a difficult example. You will understand. Okay, this is not that good a line, but anyway. Let me again go back to the x squared minus 1 function, right? So we have x squared minus 1 absolute value. When I wanted to do absolute value, I reflected this off like this. Is that clear to you? Correct? How will I define this function? Absolute value of x squared minus 1. Well, I will define it as 3 pieces because I have a piece here, and a piece here. Do you see 3 pieces now? So absolute function is a piecewise function. Now, one piece is, I could write that this particular piece, when x value is actually greater than minus 1, okay, greater than, let's say, minus infinity, and let me start from here, less than minus 1. So we are talking about the left piece. Left piece is exactly same as the function itself, right? So we'll say this is x squared minus 1 because we never reflected it. Similarly, the right side, where we say that x is greater than 1, we still have the function x squared minus 1 because we did not reflect it. So these 2 pieces we did not reflect. Do you see that? Correct? But we reflected in between. That means I'll write it in different thing. Between minus 1 and plus 1, it becomes negative of x squared minus 1. Is this clear to you? Because we
I have a question, sir.
Yes.
The green part, it cannot go below negative 1. Like, cannot just go, no, it just stays, okay.
Yeah, so at 0, we just figured it out. 0 remains at 0. We call these points as invariant. They remain exactly same. But the other in between gets reflected. And reflected with, this was minus 1. Minus 1 becomes plus 1. That is what it is. So I made negative outside. Do you see that? That is how you're going to make absolute function. Is this clear now? Slightly tricky. And that is the reason why it is the least understood part of advanced functions. You're getting it right? It is not easy. We are going to visit this again and again many times because in all the chapters, we will get absolute function combination. Okay. Now, let me also get to inequalities at this stage. Now, when we talk about inequalities, we have kind of inequality definitely means what? We're talking about greater than, correct? We say, well, 7 is greater than 5, right? We say, well, 3 is less than 4, less than, or we could have inequalities with, let us say, x is greater than equal to 0. That means on the right side, correct, of the number line, including, right? So inequalities include greater than or less than sign. Equal to sign may go in their combination. That is very important to understand. On a number line, how do we show these inequalities? That is the kind of solution, right? If I have something in between, for example, here, right, look at this place. In this place, you will notice that I have a segment which I am showing in blue from -3 to +3. You see this portion, -3 to +3? In this -3 to +3, I have circles which are not filled in. Not filled in means -3 not included, +3 not included. What is included is anything in between plus and -3. So we are saying absolute value of x is less than 3. You get the idea? Absolute value of x is less than 3 means a value which is between plus and -3. Clear? But on the other hand, if I say absolute value of x is greater than equal to, when I have equal to sign, I have filled in the circles. Do you see that? And going away from 3 and -3. Both cases, absolute value is greater than equal to 3. If I take a value, -4, for example, then -4 absolute value is 4. 4 is greater than 3, right? It satisfies the inequality. Is this part clear to you? The number line relation with the absolute function. Is this clear? So, absolute means either within, when it is within, less than, away from, greater than. So if I say absolute value of x greater than 7 means away. Both sides, less than -7, greater than +7. Within means within plus and -7. Is that clear to you? That is what it means, correct? So that is one particular concept which we are going to relate with. Now let's look into equations. I've skipped some part because we'll do it as an exercise in the book, right? When I say absolute value of x is 10, it means x is equal to what? Tell me. Hamza, can you answer this question? Absolute value of x is equals to 10. X equals to how much?
Would x equal to 10?
Plus and minus.
Oh, okay.
Both will be 10.
Okay, yeah.
You get my point? Simplest question of all.
Yeah, oh yeah, because -10, if you put it would become, okay. Yeah.
Very important. Now, Mohammed, answer this question. And don't feel bad about wrong answers, okay? Don't feel bad about wrong answers. The whole idea of my asking you simple questions is to make you aware how careful you have to be with this chapter. It is not an easy chapter, okay? Absolute value of x is -5. Mohammed, can you tell me solution of this equation, please?
Would x equal to 5?
5 will give you +5.
Yeah. Is that what it is?
What is the answer then? What could be the value of x which will give you -5 as your answer? Anybody else?
Would it be x equals plus -5?
No, both will become +5. You see how tricky it is? There is no value. Yes, yeah. Yes, Akshat.
So I was going to say it does not exist.
Correct. It does not exist. There is no value of x which will give you -5 because absolute value is always positive. You understand the power of does not exist? That is how you are going to answer this question. You get the idea? Okay. Now, we'll go to a difficult question, which is 4 minus 2x is equal to 8. We'll try to solve this particular equation. Is that clear to you? Okay. Now, how will you solve 4 minus 2x equals to 8? Tell me. It really means what? You could solve like this. 4 minus 2x is equal to, it could be equal to 8, and 4 minus 2x could be also equal to -8, correct? Because both plus and minus will give you +8. You get the idea? Now it becomes simple. I can solve these equations, get my answer. Is this point clear to everyone?
Sir.
Yes.
I just wanted to confirm. So using the same concept, right? So if we do see, right, x absolute value of x minus 4 equals to 2,
Yeah.
it would simply mean x minus 4 equals to -2 or x minus 4 equals to +2, right?
Correct. Both the equations solve them.
Okay.
So easy. Now it's easy, right?
Yeah.
Second one. What will you do? You first divide by 12 by 2, right? You get x minus 1 equals to plus minus 6, right? We divided 12 by 2. We got 6. And therefore, we'll write x minus 1 is either plus 6 or minus 6, and we'll get two answers. Of course, because if I have this graph, and if I draw this line, do you see it intersects at 2 points? Both the answers are correct answers. If you miss one of them, wrong answer. Is that clear to you? Okay, one more question. X plus 5 equals to 0. Tell me what is the answer of this equation. Absolute value of x plus 5 is 0. What is x equals to? Anybody? What will make it 0? X plus 5 equals to 0. Plus minus 0 means 0 only, right? So what is the answer?
Is it undefined?
No. X plus 5 equals to 0. Solve it.
So would x be -5?
Yeah. Simple. So except for when it is 0, you got one answer. But for all others, you have two answers or no answer. Do you see that? If it is negative, no answer in this particular situation. Is this part clear to you? Sometimes my question will be, how many answers do I have for this equation? I'm not asking for answers. I'm saying, how many answers do I have for this equation? Then that will be your answer. Is that clear to you? Okay. This question becomes tricky. When I do absolute value of x squared minus 1, I could have 3 answers, correct? Let me just show you. We just now made a graph of x squared minus 1 and it was looking like this, right? Something like this. Is that clear to you? We reflected. So if I am saying some value, I could have 1, 2, 3, 4 answers. You see that? I could have 2 answers. I could have no answer. I could have 3 answers. Very tricky question. For example, if I say absolute value of x squared minus 1 equals to 1, that means I'm looking at this particular line. Is that okay? I've got 3 answers. If I say is equal to, let me just write like this, and seconding, x squared minus 1 absolute value is equal to 2. That means I'm looking at this place. I got 4 answers. Correct? And if I say it is equal to half, then also 4 answers. If I say minus, of course, 0 answer. So depending on your equation with absolute function combined, it can become very complicated. You see how I have taken very simple question, x squared minus 1, right? And gives you so much of complication. Now you understand the beauty of it. Okay, very good. So we have already done this. Now let's look into the number line. And this is going to be my last example for today, okay? We already seen that if I write absolute value of x greater than equal to 3, it means that we have included the points which are plus minus 3, and we are going away from these. And on the number line, the red arrows are showing me the solution. Clear? But if I have absolute value of x as less than 3, it means we have every point in between plus and minus 3, but not including plus and minus 3. Because the inequality is less than 3. It is not equal to 3. Is that clear to you? Correct? So always take care whether we have, if I have equal to combined with the inequality, then you have to fill in the circle as it has been done. If it is not there, open circle. It is not included. Is that clear? Very good. Now, okay, so I'm not going there because, okay. Correct. Some very interesting examples here are, write the following solutions as absolute function. Now, this time I'm doing the reverse. Last time we solved the equation and wrote the answer, right? We had the absolute function. Now I'm saying my solution is X is plus minus 4. What is the equation? What is the equation for which the solution is X equals to plus minus 4? Tell me, anybody. Mohammed, tell me. This is my solution. Read the question, Mohammed, please. Example 2.
Write the following solutions as an absolute function.
Correct. Solution is X equals to plus minus 4. What is the absolute function which will give you this answer?
Is it X equals to absolute value of 4? I mean absolute value of X equals to 4.
Very simple, right? Correct. How about this? Now we want minus 3 as the answer. Only one answer. What is the answer? Tell me now. Anybody?
Absolute value of X plus 3 equals to 0.
Very good. If you have only one answer, it means equal to 0. Otherwise, 2 answers. You get my point. Tell me the answer of this question. X is not equal to 5. Now, what is the value? Write it in terms of absolute function. Bonus question for you. You cannot see such simple questions anywhere, but this will like become so complicated.
I have a question.
Ask.
Is this like an equation, like for example, it can have multiple solutions, but one of them cannot be 5, or is it just...
Yes, it could be, yes. Tell me. X is not equal to 5. Definitely, this is like equation which is not equal to, right? Try. Hamza, make an attempt, please.
I'm not sure.
Okay, tell anybody. We have a similar example here. Yes, please. Yes.
I'm not sure, but is it absolute value of X equals -5?
No, then the answer will be no answer, right?
Okay.
Hint. Example C is your hint. We have equation equal to -3. We got the answer. Now here we have not equal to 5. So what will I do? Tell me. Make an attempt. Akshat, tell me.
Sir, this might sound silly, but maybe you can have an equation that just doesn't have 5 in it. Like,
yeah, tell me. Correct.
So maybe you can take the same equation as C. Would that be correct?
No, equation X minus 5, right, is not equal to 0. Or in that case, or you can say X minus 5 is greater than 0. If I say X minus 5 greater than 0, it means what? It means X can have any value, not 5. Because if I put 5 there, I get 0. If I put 5 there, you get 0, correct? Any other value, it is greater than 0 because it is always positive, correct? Very good. So that is the complication of this particular unit. I would like one of you to share the book. Akshat, I think you have the link. You share your book and we'll quickly go through all the questions in the book. You should be in a position to answer them straightforward. And I'll add one more question at the end. Okay, Akshat, can you share?
Sir. Yes, sir, for sure.
Let me stop sharing this and then we'll get back to this and give you, that liberty of sharing. Okay, very good. Yes, Akshat, please share the book. Now, all of you, is everything clear up till now? Okay, move on to the exercise. This is one page, right? Move. Done. The chapter is over. Did you see 1 hour? I was just talking like mad. I could not cover what I wanted to. And this book has only 1 page of it, correct? That's the reason why 75% cannot answer any of the questions which will be there in the test paper. I'm asking you questions from previous 10, 15 years of test papers, which students could not answer. Now here, these are simple questions. Akshat, can you go very fast through? Very simple, arrange all this, right? Go to number line. Question number 5, please. Answer. Rewrite using Absolute value notation, first one. You're looking into value between plus and minus 1, 3. What is the equation?
So, sir, it would be the absolute value of the
Would it be
absolute
the
value
absolute?
of x.
Tell me,
sir,
mom. Yeah, tell me anybody.
Would it be the absolute value of 3?
We are talking about an interval. Whenever there is an interval, it is inequality. It has to be less than, greater than, less than, equal to all those combinations, not a point. Okay. So now tell me, what is the equation for 5a?
So would it be absolute value of x is less than or equal to 3?
Because the points have a hole filled in circles, so less than equal to 3. Is that clear? Perfect. Next equation, Ankita, can you tell me?
So would this be like an interval as well?
Yes. What interval?
The absolute value of x would be greater or equal to 2.
Open hole, no equal to, greater than 2.
Oh, because there's no, okay, yeah, I get it.
Okay, Mohammed, tell me answer for 3. C.
The absolute value for x is greater or equal to 2.
Correct, because it is included. D. Hamza, answer for D.
Sorry. X is greater than equal to
within. Whenever it is within an interval, less than. Okay, and open hole means only less than.
Okay,
and
so it's greater than less than 4.
Clear, right? Now these are the simple examples which are there in the book. Let me give you the test example. Okay. Bonus question for all of you. My number line. I am saying let me include the value. Okay. Let's say this value is minus 10 and this value is plus 2. Now I'm not using symmetry as the book has given. I'm saying this is my function. This is my solution. Now tell me the absolute function which can represent this as my solution. Please do it and tell me. Anybody?
Sir, so since the circles are shaded, we would include the equals to symbol.
Yeah, and equal to sign will be included in inequality because they are included, filled in circles. Both yes, minus 2 and 2, minus 10 and 2 are included. How will you do it? Mohammed, can you tell me the idea? How are you going to solve this question?
Wait, can you actually repeat the question?
You have to write this solution. It is same as this. Rewrite using absolute value notation, except for the book has given you very simple examples, correct? You could easily answer them. But I have not given you symmetrical points. I'm saying from minus 10 to 10, minus 10 to 2. What is the absolute function whose solution will be this? How will you do this?
You would get, it would be,
by the way, this is going to be the test question. And what I was saying is, now it makes sense, right? Most of the people will not get it.
Sir, so, I don't know. Sorry.
Yeah. Tell me, Ankita.
This is like a wild guess, but is it negative 10 less than or equal to the absolute value of x, the less than or equal to 2?
No.
Okay.
What you're trying to say is writing as an inequality. Okay, you are saying this, right? That is correct, but there is no absolute value here, right?
Sir?
Oh.
Yes, yes, Akshat.
Sir, just to take a guess, sir, would you find the sum or difference of minus 10 and 2 and then use that number?
You are very right. Excellent. What you are going, absolute value, let us now understand. It has even symmetry kind of a V. We have to find the midpoint. First, find the midpoint of this, right? What is the center value of the two limits given to you? So minus 10 plus 2 is minus 8. And when you do half of it, you get minus 4. Does it make sense to you? So you come to the middle of it. And from the middle, you say, well, I want to be within this radius. You get the idea? That's my coordinate plane reference point. So I go to -4. And how much away am I from here? I am 6 units away. Do you see that? I am 6 units away from both the ends. Does it make sense? First step, find the midpoint. Second step, how far are you from the ends? You are 6 units away. Now tell me the absolute function, which is going to represent this as your solution.
Sir?
Yes?
Just a quick question. So
Yes.
would you sum two of the sixes together, or would you just write?
No, we just found what is the difference between 2 and -4, which is 6.
Okay.
Right? What is the difference between -4 and -10, which is 6?
Okay, sir. So
Distance means positive value.
Okay,
so,
yeah.
Correct. So find the midpoint and you know the distance, correct? Or you can find the total distance divided by 2. You know how far you are from each place. So now tell me the equation in the absolute function form.
Is it the absolute value of x minus 4? And then it would be
we are 6 away.
So would it be less than 6?
Equal to, because it is filled in.
Okay.
You made a very good attempt, Mohammed. Well done, but there is a mistake. There is a mistake. Hamza, can you look at the screen and tell me, we moved 4 units to the left, and therefore, what should have been the absolute function? Mohammed, you can have a second attempt. What is the mistake in your equation?
It is my
when is this 0? We want it to be 0 at -4.
When it's +4?
Yes. Now it is the correct equation. X plus 4. We moved left horizontally. Means +4. It is 0 at x equals to -4 as we wanted. Do you see that -4 here? Does it make sense to you? Is this point clear to everyone? Hamza, is it clear? Vishruta, is it clear?
Yes.
Yeah, it makes sense.
I'm telling you, 90% students will get this wrong.
I think I need to practice a bit more though. I'll go over look before next class. I'll go and practice it a bit more.
And that's the end of it. I mean, do you understand? This is the end of your chapter in the book. But what I have taught you is wherever the absolute function will be used in your book, whether it is this chapter or rational function, polynomial, trigonometric function, you will be able to solve the question. Not only these questions, you get my point. And any question in the test paper will be now solvable by you. Is that clear to you? Okay, so we'll stop sharing the screen, okay? And now I would like you to summarize today's lesson, and I want to know from you, how much did you learn from it, and what you did not learn, and how do you like about it? So Hamza, can you begin with and tell me, how was today's lesson? What did you learn?
Today's lesson, before this, the only really things I knew was like the parent function of an absolute function, and that a negative value would become a positive. But then I learned like the symmetry and like how like a parabola, if you were to reflect it, like the absolute value would just be like the top half, and it wouldn't touch, and it won't touch the bottom half, like the negative axis. So I learned that. I didn't know that. That made lots of sense to me.
Very good. Vishruta, how about you?
I learned about the piecewise function and how to write the domain and range of that.
Very good.
And I learned about reflecting like the negative into positive of the function.
On the x-axis, correct. Mohammed, how about you?
I learned about the undefined and not exist. I didn't know that before.
Very
and also, I learned how you reflect it on the x-axis when it's like an absolute value.
Perfect. Ankita, what do you have to say?
So for absolute functions, I learned that they are non-negative. And then I also learned about the difference between non-negative and then positive integers. I actually wrote that down because I felt like it was important too. And then I also learned about how like the intervals and the different characteristics of absolute functions, for example, the end behavior, as well as, you know, like how you have to reflect over the x-axis if it's in a positive quadrant, or sorry, negative quadrant. So yeah.
Very good. Ankshit, can you summarize today's learnings?
Yeah, sir. So about absolute functions, what I found really interesting is the difference between undefined and does not exist, because that plays a really critical role when determining like the equation for the absolute value function. And I think in all the before classes that I've taken regarding functions, they've never really touched upon it. But in this class, we like really went in depth, and I learned about like all the main characteristics which make up the function. So that was really interesting.
Very good. Okay. So now with this, you can definitely do all the questions in your book for sure, right? So, but even then, if there is any difficulty, feel free to post your questions. I'll immediately on the same day give you the answers for those. Plus, search for my videos. I'll also share some videos on this particular chapter. As I've been saying, this is one of the most important chapters in Unit 1, the most important chapter of Unit 1. You must have seen the weight of this while we went through all this, correct? That one pager in the book just does not justify it. And therefore, do at least 10 examples on absolute functions if you really want to score more than 90% marks in advanced functions, because this is the place where you can lose 10% marks straight, correct? So that is why it is very, very critical. So we'll end our class here and we'll continue with our Tuesday, Thursday classes as usual. All the best and have a good night. Thank you. Bye.
Bye, sir.